Can a DC motor's performance be affected by temperature? By Logan Gillis and Kenton Summers.
Our science fair project is to test the effects of temperature on a DC motor. Our hypothesis for this test is that, or our hypothesis for the test was that the higher the temperature got, the less efficient the motor would be. And originally, our project was going to be to compare the efficiency of diesel electric motors in trains, to semi trucks to see which one was more efficient for moving cargo around. But we eventually decided to change our project to this because we thought it was more relevant to us.
DC and DC motor stands for direct current. This means that the current only goes one way through the wire at any given time. Well, this is opposed to AC because the AC stands for alternating current, which means it goes both directions at the same time. DC motors are used in simple machines for a variety of different purposes. There are four kinds of DC motors: permanent magnet, series wound, shunt, and compound wound motor. For our experiment, we used a permanent magnet DC motor.
To do our experiment, we acquired a small 1.5 to 3 volt motor, a multimeter, some alligator clips, and a thermometer. To prepare for the testing, we attached the alligator clips to the motor and the multimeter and made a small test run to make sure that the multimeter was reading the voltage correctly. Then, we did this for time intervals between 3 and 30 minutes at different temperatures: cold, hot, and room temperature.
From our experiments, it seems that there's no correlation between the temperature of an electric motor and the electrical output of the motor itself. This is different from our research, as we've seen that as the motor's temperature increases, its output decreases. Uh, here's a table from our experiment of it in three different temperature levels, and even though the motor's temperature rose, the output did not change.
Compared to other results, our results did not seem to correlate with any of the results of the previous studies. We may have had some errors when it came to things like temperature regulation, because in the hotter areas, the motor may have cooled off too fast. In the colder areas, the motor may have warmed up too fast. And having a consistent battery charge, because using the motor makes the battery go down, and that might affect the performance in ways that we didn't anticipate. So later tests that were more exact could use larger motors and more extreme temperatures to keep a more consistent environment, so that they didn't run into the problems that may have possibly run into.
So, from what we've learned from our experiment, is that if if someone were to use a small electric motor for their projects, they wouldn't have to worry about temperatures, like the temperature environment and such, because it wouldn't affect the performance of small motors.